I've written a small C program. It's supposed to be a simple license check. So you can execute it and you can supply a key as an argument and it will be checked. Our goal is to crack this program so we don't have to use a valid license key. I've made this program available through a GitHub repository. You can download it from github.com/liveoverflow and the repository name liveoverflow YouTube. Or you can install Git with sudo apt-get install git and get the whole repository with git clone and the address you can see on GitHub. We will probably talk more about what Git is later. For now, it's enough to know that it's a way how developers can program together on a project, and I use it to share some stuff. To have a look at the binary assembly code, we can use a program called GDB, the GNU debugger. So type GDB and the path to the binary. So every C program has a main function, remember? So let's type in disassemble main, which will display all assembler instructions from the main function. But do you see how ugly that looks? That's horrible AT&T syntax. So type in set disassembly flavor Intel. Remember that you can use tab completion here as well. Now disassemble main again, and now it's much more readable. Okay, so it looks complicated, but you can ignore most of it. First of all, get a higher level view of it. It doesn't make sense to start going through this instruction by instruction. This main function obviously calls other functions, so just draw a mental picture of the rough control flow. I will actually print out this assembler code and use a pen. That's how I did it in the beginning and still do it when I encounter more complex code. And remember to just ignore most of the stuff. Concentrate on the actual flow. So at the start, it arrives at a compare with number 2. And afterwards, a jump not equal. So something is checked if it is 2. If that is the case, we proceed to a printf, which we know is a function to display text. Then comes a string compare. If you don't know that function, read the man page of it. man3 string compare. So this compares two strings and returns 0 if both strings were the same. After that call, we see another jump not equal. So if the 0 flag is not set, there will be a puts call. Use the man page to figure out what it does, but it just prints text like printf. So if the original compare with the number 2 was not true, then it would jump to the address 400623. So in that case, it prints some other text with puts and exits. I always add the address, or at least part of the address, from important locations so I know where I am. This will help you later when we step through the program. Now we have one branch missing, which also just prints text. Some jumps are still missing, but you can add them to get a nice control flow graph. Now let's actually execute this and step through it. You can then draw which path through the graph you have taken on your paper. To do this, we first set a breakpoint at the start of main with break main. Breakpoint is set, now use run to start the program. Starting the program, and we hit the breakpoint 1 at this address. A breakpoint is a point where execution stops. Now look at the registers with info registers. Here you can see the RIP, the instruction pointer, points to the first address in main. Now use SI to step 1 instruction. Now we are at the new address in main, info registers, and you see the changed instruction pointer. So now just step through it and follow the addresses in your control graph. But use NI instead of SI, because SI would step into function calls, but we only want to step through this main function and not follow stuff like puts. Okay, did you notice when we jumped? the jump was at 5D0. And then the next instruction was at 623. So we followed the jump, which means whatever was compared to 2 was not 2. And then the program printed the usage information after 628, which was the last puts call. So we can write down that this puts prints the usage information. Now it's pretty clear that we didn't pass a key to this program, which means the check was looking at the arguments if we supply the license key. So let's run the program again, but this time with a random license key. Yes, we want to start the program again. Now do the same NI, NI, NI. Now we are at 5D0 again. Will we jump this time? No, cool. So the next branch we expect is at 609. Let's NI and see what happens. Ah, another print text. So that printf is the info that a license key will be checked. NI, now comes the branch. Okay, we arrived at 609. Let's see where we are afterwards. At 617. So we did jump, which means that the string compare failed. And when we continue with an I, we see that it's wrong. Okay, let's set a breakpoint just before the last compare and run the program again. Remember that you can easily copy and paste values in the terminal by simply marking something and pressing your mouse wheel. Now run again. Breakpoint 1. Now continue. This will run the program normally again until we hit the next breakpoint. Now it stopped before we execute the test EAX EAX. EAX just refers to the first 32-bit of the 64-bit RAX register. So its value is hex E. Let's set this to 0, which would indicate that the string compare was correct and returned a 0. Set $EAX equals to 0. Info registers and you see that it's now 0. Now use an I again to step and follow your control path. Access granted. Yay! So we circumvented the license check. And you can always write your own little C program trying to make it more secure and then crack it yourself again. You will notice that it's impossible to make a program uncrackable. Those kind of challenges are called crack me. People create small programs that have to be cracked, or more often you have to create a valid keygen. If you think something like this is fun, check out crackmes.de. Creating control graphs like we just did is pretty useful. That's why there are some programs that do that for us. Here are 3 different examples of this specific control graph. First is from the Hopper disassembler, second is from IDA, and the last one is from Radaret. See you hopefully next time when we use some different tools to explore this license check binary a bit more.